Good afternoon and welcome back to my workbench on this lovely rainy Sunday afternoon where I've got an old graphics card with blown capacitors that I've, well, been saving for a rainy day just like this one, and I thought I'd make a video about, well, maybe replacing the capacitors on it, and more importantly really I think I want to look at sort of if you have a graphics card like this, or maybe another piece of equipment, but specifically graphics cards, sort of looking in depth to see, well, is it actually worth it? Because there can be some hidden problems that you may not notice at first glance about a video card in this sort of state. So I want to sort of go over what to look for and to check to see if it's worth your time and money and effort to actually bother trying to repair one of these. So that's kind of what I'm going to do myself, because I don't really know what state this is in, and I want to personally figure out if it's worth doing anything with. Now, I recently built another computer to run this monitor and to use on the workbench for video recording instead of using the desktop over in the corner there, because that was a bit annoying, and I want to use this just specifically for that, so I don't have to it's just easier to have two separate systems. But this current system is running off the integrated graphics, which are not that great performance, and also there's some kind of driver or kernel bug with Linux and that particular chipset or series of chipsets anyway, and I'm getting like boot lockups and weird stuff unless I turn mode setting off for the graphics card, but that disables the driver, and then there's no acceleration, so performance is even worse, and the resolution isn't correct. So yeah, it's not that great, but considering the performance is bad anyway, I really want to have a discrete graphics card in that machine, and I don't have anything lying around that I can use that's any good, but I do have this, and it might be good, so I want to investigate this and see if it's worth trying to get it going. But I am going to say right off the bat that this is an 8600 GT, and as you may know, the GeForce 8 series was one of the major issues with NVIDIA products at the time, especially in laptops, but also the graphics cards as well. Basically, the GPU die itself becomes disconnected from the VGA carrier, and this is due to some underfill issue. It's usually called bump gate on the internet, and it's I mean, you can maybe fix them with a reflow or at least sort of resurrect them for a while, but I think if it's had a hard life and it's run hot quite a lot, it's maybe not that worth it, and it's probably won't last very long. So up to you, I guess. You can take that chance, or if you want to reflow it and see what happens. If you have a card in that era, that sort of model line, I can't remember if the GeForce 7 and GeForce 9 was affected as well, but definitely GeForce 8 series, most of them or all of them were pretty dodgy. So this particular one, though I do know a bit of the history about it, and it was given to me by a friend of mine, and I don't think he used it much for gaming until he bought a faster card, and then it just was sort of used in an office computer for a while, and shouldn't have been running too hot or anything. So I'm hoping that the GPU is actually okay. At least should work for a couple of months or so. If I can get even a month out of it, that's fine. It gives me time to buy something else. I've been looking online, but I can't really find anything that's suitable. Most of them, the price is not too good, especially when you factor in postage, so I want something I can pick up locally that's only going to be like $10-15. I don't have to worry about it, and something that's decent quality, already has good capacitors on it, and already has good heatsink and all that. So I was waiting for something good to turn up, but in the meantime I thought, well, hey, maybe I can try and fix this and use this until I get something better or whatever. Anyway, so basically this video is not just going to be, well, the idea was maybe to do this as a repair for this, but more specifically, what I want to really do is make it as a video about sort of, I don't know what you'd say, appraising an old video card, if that makes sense, to determine whether or not, I guess really, if it's actually worth investing any time and money in to try and replace the capacitors, and whether or not there's any point in doing that. So with this one, like I said, it's GeForce 8, so maybe it's not worth it to begin with, but there are three main things you can do to start off with. Onto quick tests, which I would do to determine whether or not there's any point in bothering to proceed. We can have a look at those, and I'll go more in depth and explain what I'm looking for. And these are things you can apply not just to a GeForce 8 600, but to pretty much any graphics card. Do a quick indication of whether or not it's whether it's completely dead, or if there's some chance that you might be able to fix it. Okay, so the first thing I would look for with one of these, or with anything really, is to do a quick inspection and see if you can notice anything visibly burnt or blown or cracked or whatever. Now obviously, apart from these capacitors, which are completely blown, there's nothing, especially on this card, there's nothing obviously trashed. Now I'd say most likely what you want to check for is the MOSFETs here. Check if there's any cracks or burn marks on these. In this case there isn't. Also check if the PCB is discoloured. You can check the backside as well. There's some more MOSFETs here, and another one over here I think. But basically everything on this card actually looks pretty clean, pretty good. There's nothing really burnt, nothing obviously damaged. So that's a good start. Next up, I'd say to check the fan. So what I mean by that is just to have a look at the condition of it. Does it spin freely, and how much dust in it basically. So this one doesn't have a heck of a lot of dust in it, which means that the thing shouldn't have been running too hot. Also the fan is quite loose, spins freely. If you give it a quick push, it goes around, and very light. And you can also put your finger on it. It should be very, very smooth when you turn it, and that indicates that the fan's been working fine. There shouldn't have been any dust build up. The thing shouldn't be overheated. If the heatsink is completely stuffed full of dust, if the fan is very hard to turn, you're looking at a card that quite possibly has been severely overheated at some point and may have had GPU damage, whether it's an 8600 GT or anything else. But in this case, there's not much dust. The fan spins freely, so that's another good sign. So it shouldn't have been running too hot. In comparison, if I take another card, like this old Radeon here, which is pretty much dead, you can see the fan itself does not spin as freely as the other one. As you're able to see, when I flick it, it doesn't turn nearly as many revolutions, and it sort of stops quite suddenly. And also if I do it touch like this and turn it around with my finger, I can feel sort of a resistance. It doesn't feel so smooth as the other one. So there's a good indication. Also, if you run the fan, you can unplug the thing here and run it and listen to it if it sounds really terrible. The fan could have failed, but this one isn't completely seized up, but it's not that great really either. And this could be why this card's failed. It could have overheated. This fan might have been a problem. Also, this heatsink was quite full of dust previously. Obviously, if the fan isn't in too bad shape, it's possible you could just replace it and the video card might be fine, or you could re-lubricate it. But yeah, that's a different sort of thing to talk about. I'm not going to talk about that here. So back to this one. So you give it a quick visual inspection and give the fan a quick flick and see if everything looks okay. And yeah, like I said, this one looks pretty much fine at the moment, is for what it is. So the next step is to check out electrically two things basically. I want to check out the MOSFETs here, see if any of them are shorted, and I also want to see if it's possible that the RAM or the GPU core has been shorted at all by any other issues. Okay, so specifically what I want to do here, I've got my meter set to 200 ohms. Not worth using diode mode for this check because you can get false readings, but I wanted to use ohms mode. What I'm going to look for is, like I said, I want to see if any MOSFETs are bad, or if the core or the VRAM is shorted. So basic design of these things, in modern graphics cards anyway, but the older ones it'll be a different rail. But most of these, you've got like a little buck regulator circuitry. So what we've got here is this coil. You've got a coil, you've got some MOSFETs, you've got capacitors, you've got a little controller somewhere. And basically what it does is it takes a 12 volt rail and it steps it down to 1.8 volts or whatever, the V core volt. I'm not sure what the core voltage is for this specifically, but it's going to be a low voltage, typically like 3 or less volts, depending on how old the card is. What we kind of want to do is figure out are the high side MOSFETs on anything shorted. That's kind of our main problem. If the high side MOSFET, which is the one that connects between 12 volt and the output of the buck regulator, if that's gone shorted, then it means 12 volts will have gone directly into the GPU or into the RAM, and you're very likely going to be, the thing's going to be dead if that's ever happened. And if the capacitors have blown, such as these ones are, it's plausible that the MOSFETs may have shorted out because they're overworked trying to compensate for the fact the capacitors have all blown. So yeah, it is a risk. But in this case, we got this one here is actually a decent brand capacitor, and it's still okay. And a couple of these ones, these crap ones, are still okay. So who knows? It might be okay. But yeah, and it's also worth mentioning, I guess, that these particular ones, marked FZ, they are a very well-known brand to be absolute garbage. I don't know exactly how things went, but the FZ series came under 4 different brands, I think, that most people know of. These particular ones, Sacon, I think, but there was also Evercon, Alcon, and GSC, I believe. All basically the exact same manufacturer, exact same garbage capacitors. They all blow like this eventually if you use them for long enough. Really, really terrible. Probably one of the worst brands that ever came out in computer hardware, basically. And it's even worse because very, very fraudulent, I think. If you look at the style of these, you can see they're kind of similar to a solid polymer electrolytic capacitor, but obviously the vents on top and the vent lines you see it gives it away. They're actually just standard wet electrolytics, but some versions of these capacitors got rid of the vent stamps completely, so they pretend to be polymer capacitors. They're complete garbage and they just blow up regardless. So anyway, so what I'm going to do, I'm going to check. I want to find out basically which MOSFETs are the high side MOSFETs. I don't know because I don't have a schematic for this. But the quick way to check that is to look at and find the 12 volt input and then check to the drain of the MOSFETs. So on the PCIe connector, the first 3 pins on this front side are all the 12 volt input, and obviously this card, this is the only place it's going to get 12 volts from. On older cards it may be getting it, especially if it's an AGP card, it might be getting that from a 5 volt rail or 3.3 volt. So you might want to check what that's doing. Also obviously in some cards there's a extra 12 volt connector or whatever up around this area or up around here somewhere, so that might be being used instead of this. But for this particular card I'm going to have a look at between these 3 pins, one of these pins, and we want to look at draining these MOSFETs. So I'm going to check this one, for example, and we get very low ohms, 0.2 ohms. So I can tell straight away that the drain of this MOSFET is connected directly to 12 volts. So that's probably the high side MOSFET. Of course, it could be if the high side was shorted, then this could be one of the low side MOSFETs, and that could be just showing a short. But we can test the other 3 that are here, for example, and this one specifically we get no reading whatsoever between 12 volt and its drain, and the same for this one here. Now these MOSFETs are wired in what's called a totem pole, so generally you've got one that connects between the input rail and the output rail, and then one that connects from the output rail to ground. So we can also check that. We can take a ground point, let's just say the screw on the DVI bracket here, and we can check. Let's see, what have we got? On the input here we got fairly high resistance. We see a capacitor charging, so that's probably the input. We can check the output of this, the source. We get 9 ohms. Well, that's interesting. And if we check the source on these 2, that's a direct short to ground. So these ones here should be the two low side MOSFETs, and that should be the high side MOSFET for this particular circuit. And going by the big coil here and the amount of capacitors is probably for the GPU V core. So what it's looking like here, we check now. If we check the input of these to ground, we see we've got about 9 ohms. So that's telling us that the GPU V core is about 9 ohms. Again, if I put this on diode mode, it will show. It'll show us very low voltage, and it will beep. And you could think, well, maybe that's shorted. But given a comparison between some other cards, actually, we can say take this one, even though this one's completely dead. I'm not entirely sure what's wrong with it, but if we go from ground to, and I've already had a look at this before, but if we go here, I think it was this one, we get 7 ohms. So there we go, another lower thing. But take another card here, which is actually working. This card is working fine, but well, it's not working fine because the VRAM is actually corrupted. But if we do the same test on this, we get about 10 ohms. So 10, 7, 8, 9 ohms. This is all going to be the V core for the GPU. Pretty much all the same value, really. So what we're kind of saying is this one, it's unlikely to be shorted. That looks good. So if we measure also the just the high side MOSFET specifically, from source to drain, we don't get a short. And if we check it on diode test mode, we can see cross drain and source. One direction we get, what do we get? 600 millivolts. And the other direction we have, well, what do we got here? The other direction we got 470. And we can compare this with the working with another card. Compare that with this one, for example. There's a high side MOSFET on here. We get 900 millivolts one direction, and 485 in the other direction. So really the readings are quite similar between a working card and this unknown card. So that tells us quite possibly there's nothing wrong with that MOSFET, nothing wrong with GPU itself. So also obviously we've got the VRAM rail. Now that's these MOSFETs here. They're on the back side. This one, again, there's a high side MOSFET. We're getting nothing across that, so that doesn't seem to be shorted in any way. And we can again test this from the 12 volt part. So we can check from this drain to one of the pins. I think it's the first one is a control line, I believe, but the next two are 12 volts as well. So again, yeah, so that's directly connected to 12 volts. And then this one, the source should be connected to the drain of this one, which it is. And if we check from this drain here to ground, we get, let's see, 95 ohms. So the VRAM rail is about 95 ohms, which again, well, we can compare with this card here, and I believe it's this just uses one MOSFET on this one. Sorry. If we compare with this one, we get 80. So that's 80 ohms for that, for the VRAM on this one, and we can check this other one as well. Let's see which way. From ground, and I believe it's this one here. we get 60 ohms. So again, 60, 85, 90 ohms, all about the same really, and around 10 ohms for the GPU. So we can probably say that in this case, neither the RAM or the GPU are probably shorted. Neither of the high side MOSFETs in both those buck regulators were shorted. Low side MOSFETs don't seem to be shorted either. Basically, there shouldn't really be any problem. There's another MOSFET over here. This one, I believe, is just in parallel with this one. So it's just another low side MOSFET. If we check to that, yeah, it's directly connected to that one. And again, this will be, check across that. Well, there's 100 ohms. Across this one is, you get that 92. So yeah, it's probably feeding a different set of components. But again, it's a low ohms, 100 ohms, but it's not a short, so shouldn't really be an issue. There's this other one over here. You can check that as well. Not sure exactly what this one's doing. Oh, that's the gate, sorry. Again, there's no short showing across this in any way. So yeah, I wonder if this is connected to 12 volts as well, or is this something else? Okay, that's also 12 volts. So that'll be doing some other sort of thing, but again, that's not shorted either. So if we also check from this to ground, I'm not entirely sure what this is. Output of that, it may not be for voltage regulating, it might be for something completely different. But there's no short there, so everything seems quite okay. Obviously, if you're doing this on your own card, you're going to have to check the pin out for the MOSFETs. I already know what the pins are because I've looked them up already, but if you've got an unknown card with unknown MOSFETs and all that, you might want to check that out. And obviously you can look up the part numbers of the controller ICs, the buck controller ICs, like this one here is one for the I believe for the VRAM, and on the back side here this is the controller for the GPU. So yeah, you can look up that, find the pinouts, find out what connects to what. You can get a basic idea of how the circuit works and what to look for. But yeah, so we just want to look at, is the high side MOSFET shorted from 12 volt or whatever input rail directly to GPU or RAM, and in this case it's not. None of the MOSFETs seem shorted. The GPU and the RAM rails all have a resistance which compares fine with two other cards, including a, well, almost working one. It has yellow lines down the screen, but it still works. So all in all, I would say, in general, given the condition of this card, like I said, the fan is fine, there's not much dust, there's nothing visibly burnt apart from the capacitors blown up. MOSFETs all check out fine, resistances all check out fine. Probably if I replace the capacitors on this, it'll work. Whether or not there'll be artifacting, whether the RAM has been damaged at all, that's debatable, but there's no dead short, nothing's obviously blown, so it's hopeful. It's hopeful that this could actually function in some capacity if I replace the capacitors. So I think I'll just do that, and we'll see what happens. Basically, hopefully it'll work out, and if not, well, hey, at least it was a bit of useful information, hopefully, but we'll see what happens. Now something I obviously forgot to mention, but which hopefully should be obvious, is obviously first thing I did was visually inspect the card and check it for damage and then do some electrical tests on it. The first thing obviously you should definitely not do is plug it in and see if it goes, because if there is any issue with it, and if it's has got blown capacitors on it, it's quite likely there could be something else will go bang when you turn it on. So it's a good idea if you've never plugged it in, to not do so until you've at least replaced any obviously blown capacitors or anything like that. If you really do that, because otherwise it's quite possible that you're going to blow something up. I mean, if the controllers on the voltage regulator controllers on the card shut down by themselves due to faulty capacitors, or the computer powered off due to an overload or something, you might be lucky. That might be the only thing that goes wrong. But if you have some bad capacitors and you start the thing up again, it's quite possible that the voltage regulator circuits may be unstable when they try to start up, and you could get voltage spikes to the GPU or the RAM or anything, and could cause damage. So really good idea not to power it up straight away. As exciting as it may be, and as much as you might like to want to verify if it's worth it, it's, if it is an okay card, you don't want to really risk killing it by doing that. So not worth doing that sort of thing. You could even damage your motherboard. So very very unadvised to do something like that. Yeah, sorry about this video. You may not be able to see a huge amount in this due to just the lighting on this card and the fact that it's black, matte black, and sort of the getting decent light to come on this thing is quite hard. But anyway, so that's the 470 microfarad capacitors there. That's that done. So I'm just going to chuck these dead ones over here out of the way, and we've still got one left for the good ones. I'll put that out of the way as well. So now we got the let's go take the 1500 microfarad. I think that was these ones. Yep. So we got 3 of those, and I guess it's worth noting these ones are quite a bit taller than the originals. Again, this is going to be a problem if you care about fitting this into a case where you've got something directly underneath, because this will be quite tall. It'll stick up off the card, probably take up more than one slot, but you could always also lie these over if you wanted to, but I don't really care about that so much. Again, what I'm using it for, there's enough room that it doesn't matter, and it's easier for me to just do these straight up and down, so that's what I'm going to do. I guess I've got to take the old capacitors out first as well, so I'll put these new ones over here. Right, so let's get rid of these old crusty ones. This one looks like it's going to be quite easy. Yep. Ah, that was nice. Came out very easily. Now, of course, you can heat and push these capacitors to get them out, and you can also do the same thing when you install the new ones as well. You can cut the leads down short, and then you can start pushing them through the holes while you heat the solder up, and that can work quite well too. But I think with this particular board, I think even that would be a bit of an annoyance, so I'm just going to go with the easiest route and to use those surface mount pads on top. So I think that will be far less annoying than anything else. Ouch. I'm just cleaning up the opposite side of the board to make sure there's no solder spikes or anything sticking around that could be shorting out to any other components or anything. Just want to take that off. So these were all 1500 and that one's a 1000, 6.3. So actually I think I'll pull that one off now because it'll be easier than if I try and pull it off once I put another capacitor on next to it. Right, so that's got rid of all the junk capacitors and all the blown ones. Maybe that one leave its lead in the hole. Or is that just a spike of solder? No, that was just some solder, okay.
I'm scrubbing the iron around a little bit on these pads here on the top because they have a little bit of oxidization on them, so I need to sort of get a little bit of space there. Anyway, so let's go, what's this, 1006.3? Let's do that one first so I don't confuse myself. That's in the bottom right corner. It's this one here. And there's another thing to note when soldering on these things, especially with surface mount parts, even though these aren't really surface mount parts, but they are now. Especially with surface mount things, but sometimes with through-hole parts as well. It's often easier to, depending on how the board is laid out, it can be easier to solder certain parts first, so you've still got clearance for your iron to work on the other parts once they're in there. So, you know, depending on how the thing goes together. Usually if you've got a group of components quite close to each other, it makes sense to solder to desolder the outside ones first and then solder in the inside ones first once you're doing the replacements. But it will depend on the layout and which direction the pins are in, so that doesn't always apply. But yeah, it's worth to take a note of that sometimes and just be sure that what you're soldering in where makes sense. For example, it's a lot easier for me to get my soldering iron in on this side than it is to get it on that side, because that capacitor there is in the way. Just want to make sure that one actually flowed on properly. Anyway, that looks right. So almost finished. And I guess what I've really got to do is hope that it actually works, because well, it's not a big deal if it doesn't work, but it'd be nice if it did. So there we go. dodgy old GeForce 8600 GT with some brand new Rubicon Panasonic capacitors on it. They're all Rubicon except for that one, which is the Panasonic. There we go. So, like I said, the height is a bit of a problem, but for me it doesn't really matter. So, there we have it. So now the only question remaining is, does it work? Okay, so I don't know if you can see this, but this is the computer I want to use for workbench work and recording video and everything. So this at the moment, actually I've got a I think Radeon 7500 in here, an old PCI card, which I was using to test out how everything worked. So I'm going to take that out and just proving my point about the video drivers and all that. So we can take that card out and we can put this one in. So I have not powered this up before, this is the first time putting it in here. So we'll definitely be able to see if it works or not. If it fits into the slot. Tight fit in that case, but anyway. Okay. Now we just need to plug the video cable in. And I need to plug in my keyboard and everything, which I was currently using on the other machine. Let me just check that. Alright, question is, does it actually work? Well, we'll see. So obviously you should be able to see hopefully on the screen there if anything happens. So, turn on, video card fan is spinning. See if you get anything on the screen here. Ah, look at that. Let me just check the BIOS settings here. Hang on. Well, that's good. Hasn't gone up in flames. We actually get some stuff on the screen. I just saw the VGA BIOS message there. Alright, so where was the thing? So let's change that to this. Internal graphics. Well, it'll automatically turn itself off. There we go. So how about that?
that's pretty cool. Basic tests indicate it might actually be working, so I should be able to just boot that and we'll see what happens. Unless the video drivers get confused because I was using a Radeon before, but it should work, I think. Okay, that's totally off the side of the screen, but whatever. Alright, let's see what the display mirror screens. What? Doesn't make any sense. Okay, I don't know why it's showing two displays here, but let's apply the correct resolution and see what happens. That's very strange. I don't know. Yeah, I don't know where this second display is supposedly coming from, but can disable that. I don't know, that might be the onboard graphics or something, or I don't know. But anyway, at least seems to be working. No graphical corruption or anything there, so that's pretty nice. If I can get temperature readout of that, possibly. There you go, 44 degrees. So it's running at 44 degrees at the moment. That's on idle on the desktop. That's not too bad, I guess. 45. I mean, hey, it's running. It's not blowing up, and there's no artifacting that I can see. So, yeah, alright. Okay, well, so there we go. The graphics card's in the computer. It's working fine. It solved my boot issue. The computer just booted right up first time. No problem, no freezing. So it seems to have solved that problem with a decent graphics card. It's running pretty good. We've got 47 degrees at the moment, just idling on the desktop. And if I open up a PDF, I can scroll through that nice and smooth. So not laggy and choppy like it was with the integrated graphics. So that's a good thing here. So as for how long this card will last, like I said, it's an 8600 GT. They are known to have problems. How long it lasts, I have no idea. But hey, I mean, it's working at the moment. If I get a few months out of it, I'm happy with that. Again, when it dies, I don't really expect this to last more than a year, I suppose, to be honest. If it lasts up to that, I'll be pretty impressed and pretty happy with that. But whatever happens, I mean, whenever anything happens to it, I guess I'll just pull the capacitors off and I can use them for something else. So it's not really any money lost. I got it for free, and that's pretty much it. So not bad, but it just goes to show. Yeah, I mean, hopefully this video was useful to give you some ideas if you do have an unknown graphics card with blown capacitors or bulging capacitors or something. You want to check it. And if it's worth trying to fix or not. Obviously this one seems, I guess, it was worth it. Yeah, so just a good idea to check those resistances, check make sure there's no MOSFETs shorted again. If the upper MOSFET's shorted, even if the rail shows, not a dead short on the rail as I showed you. I mean, 10 ohms seem to be a pretty average sort of value for these cards, and these other two that I had here, and about 100 ohms, 100 ohms on the RAM rail. It seems to be a fairly average sort of value. If you get something around those two values for those rails, resistance measurement to ground, then probably nothing's shorted. You might be okay. Again, I mean, there's no artifacting, so it is possible you might get a card that the resistance measures okay, but the RAM might have been damaged or the GPU might be damaged, so you might get artifacting. This particular one, there isn't any artifacting, so I guess I'm lucky with that. But yeah, good things to check, and if any of those turn out, a bit funny, or if you've got a dead short on one of those things, then maybe not really worth it, worth the time. But and also I'd be wary about putting graphics cards with a dead short in the computer, because you will damage the motherboard. Unlikely, because those things usually have short circuit protection, and so does the power supply, so it should either just not turn on or it should just shut off instantly if something was completely shorted. But maybe not a good idea to risk it necessarily, especially if you have an old motherboard you don't really care about. You could do that, but I wouldn't do it on a brand new expensive one or anything. You can look up this here is actually the I don't know how well you can see all of this, but this is the actually the data sheet for one of the buck converters from that card, and this does show you the typical sort of arrangement. So actually, if you can't see this, I'll overlay this on top of the video. But I mean, we've got the high side MOSFET here, which goes up to 3.3 or 5 volts or 12 volt. Then we've got the low side MOSFET. This is actually a bipolar transistor, which is designed to disable the output, but that's not used, I don't think, in this, but ignore that. We've got this MOSFET here, and that's obviously your output directly to the V core or whatever it is. So again, if that MOSFET here goes shorted, then that 12 volts or whatever goes straight through there and into the GPU. So if that's shorted at all, then pretty much lost cause. Either the RAM's going to be blown or the GPU's going to be blown. Very likely. Also, if you've got a short, if that's shorted, and also you measure dead short between this output and ground, then I mean, it's possible the lowest side MOSFET could have shorted. If, say, the high side MOSFET doesn't show a short and the low side MOSFET does, it's possible that the low side MOSFET has shorted out and the GPU is still okay, but the high side MOSFET's still fine as well. Unlikely. I don't think that usually happens. I think what usually happens is the high side MOSFET shorts and the GPU or the RAM or whatever gets completely destroyed. So you're looking for that sort of thing if you want to, before you bother replacing all the capacitors. But yeah, I guess 10 ohms on the GPU V core or whatever seems fine. And I think modern GPUs also have more than one voltage rail. This is just the basic sort of thing. You got just the V core for the GPU and the VRAM rail or whatever you call it. But yeah, check those main two, I guess. Make sure they're within. I mean, like I said, I found they were about 10 ohms for the GPU and about 100 to 60, I think, 60 to 80 to 100 ohms for the RAM, and that seemed fine. I mean, this card's working. These three. Oh, one of these was actually dead, but probably some other issue, who knows. I'm not sure what's wrong with that one, but the other one works, but it's just got bad RAM that has yellow lines all over the screen. Anyway, but there we go. If you need a comparison value, then those seem to be roughly a decent value. So yeah, anyway, hopefully that's useful for someone. Hopefully this video is helpful. Yeah, if you want to do the same thing, just some things to check. So there we go. Apart from that, I guess we're done here. So that's about it. So yeah, I'll say bye for now, and I'll see you next time.